Okay, today I'm going to lecture on the smartboard with about double replacement. Um, and so the first thing I need to tell you is that double replacement reactions, sorry, I don't write so good on this thing. Double replacement reactions have a pattern. Here is the general form. AX plus BY and goes to AY plus bx. This is the general form. Um, Here's why they're called double replacement. You've already done single. A says, hey, B, I'm going to take your place. And then because B gets kicked out, it says, okay, I'm going to go back and take your place. And so it's kind of like um, FOIL in math class, first, outer, inner, last, except in chemistry, we can't put the firsts together because two positive ions um, can't make a compound and two negative ions. So when you're predicting products, you put the outers together. So A goes with Y and then B goes with X. The other thing I need to say is a double replacement reaction only goes A, and this is the abbreviation for double replacement, a D-R reaction only occurs if AY or BX, which is a fancy way of saying one of the products, is water or a precipitate. And you guys did your very first lab in chemistry, it was with precipitates. And that's when, remember on the 8 solution lab, some of them you would mix 2 drops of a clear solution, it would turn cloudy. That's a precipitate. Um, it and it just the symbol for precipitate you'll see when I get into this is an arrow down because precipitation falls out of the sky, and upon standing, a precipitate falls out of the sky. Now, this is the sheet. It's on the back of your single replacement sheet. This is the sheet that allows you to check for precipitate because you won't know if something is a precipitate. AQ means does dissolve in water. Like when something dissolves in water, like table salt or sugar, it dissolves completely and it doesn't look cloudy. So AQ means it does dissolve in water. I means it doesn't dissolve in water. When something doesn't dissolve in water, like sand in water, you can see it with your naked eye. So on this sheet, AQ means not a precipitate. I means a precipitate. And as I get into my examples, hopefully this will become more clear. All right, so here's my first example. This is what we do. The first thing you do is you circle the two reactants. Silver nitrate is combined with calcium chloride, and so this is a double replacement. Why? Because silver nitrate is a double. It's got a positive ion and a negative ion, and calcium chloride is a double. And so the first thing I do is I write the two reactants on the left, silver nitrate, that's a double, 1, 2, and then that reacts with calcium chloride, that's a double. What I mean by that is, let me go back a slide. There has to be a positive ion and a negative ion and a positive ion and a negative ion. Remember, we were doing single replacement, you had 1 plus a, a, a double. Another way of saying it is you need to have 2 compounds. Okay, now switching colors. After you write this down, you OI it. I say OI it. This is Mrs. High terminology. It's not in any books. But I used to be a math teacher, so you put the outers together. When you put the outers together, you get silver chloride. And then when you put the inners together, you get calcium nitrate because the positive ion has to be first. You can't say nitrate, calcium. Now, switching colors, going to purple. This or this has to be water, and it's not. Silver chloride's not water, and calcium nitrate's not water. Or silver chloride or calcium nitrate has to be a precipitate. So you have to learn how to use this chart. So here's, okay, I'm going to make this small. You have it in front of you. Here's silver, third from the bottom. Here's chloride. See, it goes acetate, bromide, carbonate, chlorate, chloride. Here's chloride. Here's silver. Notice there's a little I there. So I'm going to go back. This has an I. That means this is a precipitate. Going back, I don't know if I could make this a little bigger. Here's calcium. Here's nitrate. So here's calcium. Calcium nitrate is aqueous, which is not a precipitate. And that's okay. One or both of them has to be a precipitate. If both of these were AQ, it would be no reaction. But this reaction does go because a double replacement reaction only occurs if one of the products is a precipitate or, not and, or one of the products is water. And so this reaction goes, well, if the reaction goes, then you have to write it. So here we go. Silver nitrate is AgNO3 because silver is +1 on your ion sheet and nitrate is -1. And then leave some room to balance. Calcium chloride is CaCl2 because calcium is +2 and chloride is -1. And then silver chloride is AgCl. That's the precipitate. You don't have to make the symbol for precipitate. I just do because I'm trained that way. This is silver +1. This is chloride -1. This tells me you check for precipitate. And then calcium nitrate is actually this because calcium is +2, but nitrate is -1. So you need two of them. Now to balance, let me put in my little lines. 1 silver, 1 silver, 1 nitrogen, 2 nitrogens because of the distributive law. So I have to put a 2 there. Look at, I just unbalanced the silver, so I have to go back and finish it. Skip over the oxygen. 1 calcium, 2 chlorine, 2 chlorine because of the distributive law, 6 oxygen, 6 oxygen. This is balanced when it's 2 to 1 to 2 to 1. Okay, next example. The reactants are potassium hydroxide and sulfuric acid. So I'm going to start by writing potassium hydroxide and sulfuric acid. And I'm going to say this just like single replacement. Never, ever, ever, ever do chemistry on an acid nickname. This guy's real name, just get it off your purple sheet, is hydrogen sulfate. Now, why is this double replacement? Because this is a double, first name, last name. This is a double, first name, last name. When this happens, after you write them down, you OI it, so you get potassium sulfate. And then you put the inners together and you get hydrogen hydroxide, and I'm too lazy to write that out because hydrogen hydroxide is H2O. Now, I'm going to get this other thing. A double replacement reaction goes if one of the boxes is a precipitate or one of the boxes is water. I'm not even going to bother checking this as I don't have to, because if one of the boxes is water, it goes. So now I'm going to write the reaction. Potassium hydroxide is KOH because potassium is +1 and hydroxide is -1. And then hydrogen sulfate is H2SO4. You can just get sulfuric acid off your purple sheet, or on your iron sheet, hydrogen is +1 and sulfate is -2. And so you have to do the crisscross rule. And then potassium sulfate is K2SO4. because potassium is +1, but sulfate is -2. And then water, you should know, is H2O. And then the last thing you do is balance 1K, 2K. So I got to put a 2 here. Skip, skip, skip. 1 sulfur, skip, arrow. 2 hydrogen here, 2 hydrogen here. 2 plus 2 is 4. So I got to have 2 here because 2 times 2 is 4. And then 2 oxygen plus 4 is 6. 4 and 2 is 6. And so this is a 2 to 1 to 1 to 2 mole ratio. Next one, my two reactants are iron 2 chloride and calcium nitrate. So iron 2, sorry, iron 3. I said 2, but it says 3 there. Iron 2 chloride and calcium nitrate. Again, why is this a double replacement pattern? Because double, double, or two reactants. Now I'm going to OI it. I put the outers together and I get iron 3 nitrate and calcium chloride. I'm going to grab this red pen. You do not have to do this. Here are the two products. Neither of those is water. Now we have to check for a precipitate. Is iron 3, which is right here, nitrate, which is right here. It's this box. I'm going to shade it. Iron 3 nitrate is AQ. So I'm going to go back here. This is aqueous, not a precipitate. Calcium chloride. Go back here. Here's calcium. Here's chloride. Sorry, I got two of them. This is also AQ right here, calcium chloride. This will be your favorite when this happens. Okay, let me go back to my first slide. In the double replacement, you put the outers together, you put the inners together, so you get AY and BX, and it only occurs if one of the products is a precipitate or water, not both. Notice iron 3 nitrate is not water and calcium chloride is not water, and this is not a precipitate and this is not a precipitate. And when that happens, it's your favorite. You put big X's here, and the correct answer is no reaction. When you put iron 3 chloride and calcium nitrate together, nothing happens. If you remember back in the 8 solution lab, there were a lot of no reactions. Okay, last one. I'm finishing with a fairly difficult one. This is sodium phosphate. Notice that's a compound or a double. And then that's reacting with aluminum bromide. And so now I'm going to put the outers together and I get sodium bromide. And I put the inners together and I get aluminum phosphate, not phosphate, aluminum. So first thing you do, let me just summarize, it's my last one. You write down the two compounds and then you OI them. You put the outers together and you put the inners together. And now you check. You are double, remember, if you remember the 8 solution lab, sometimes it was no reaction. One of these products has to be water or one of them has to be a precipitate. Now, sodium is right here. It's in alphabetical order. Bromide is here. Sodium bromide has an AQ. Okay, so I'm going to go back here. This is AQ. Okay, I'm checking for a precipitate. That's not a precipitate. Aluminum phosphate, aluminum is up here on the top, phosphate. Aluminum phosphate, if you look on here, aluminum phosphate, if I highlight it, it has an I. And so this is insoluble. That means it's a precipitate. So this reaction goes. Now, sodium phosphate is Na3PO4. Why? Because sodium is +1, but phosphate is PO4 -3. +1 and -3 don't add to 0, so I have to do the crisscross rule. Aluminum bromide is AlBr3 because aluminum is +3, but bromide is -1. And then sodium bromide is just plain old NaBr because sodium is +1 and bromide is -1, so we just slam those together. And then aluminum is +3 and phosphate is -3, and +3 and -3 add to 0. So this is just AlPO4. And then the last thing you do is balance 3 sodium, 1 sodium. I'm going to put a 3, 1 phosphorus, 1 phosphorus. Skip over the oxygen, 1 aluminum, 1 aluminum, 3 bromine, 3 bromine. And now go back and hit 4 oxygen, 4 oxygen. So this ends up being a 1 to 1 to 3 ratio. Now, I know that this lecture isn't very long, but you have a rather long worksheet. So start by doing, again, just summarize. First thing you do is write down the two product or the two reactants. Then you put the outers together and then the inners together. You check the product side because and one of the products has to be water, which is H2O, or one of the products has to be a precipitate. This is how you check for precipitates. I means precipitates. AQ means not precipitates. If there's nothing written here, that's because that compound doesn't exist. If there's a dash there, something happens like it doesn't dissolve in water. It actually reacts with water. But so just know that all the problems you get, you'll never get a blank box like that. This is a sheet you check with precipitates. The way you check for water is water's real name is hydrogen hydroxide. And the other thing, going back to this slide right here, never, ever, ever do chemistry on an acid nickname. So change sulfuric acid to hydrogen sulfate. Change nitric acid to hydrogen nitrate. They're all on your purple sheet. All right, good luck with your assignment.